Question number 101. In figure below, curve A will be applicable when thermal conductivity of material. Option A, increase in temperature. Option B, decrease with increase in temperature. Option C is a very large. Option D is a constant at all the temperature, and option E is none of the above. Correct answer is A. It will be increase with increase in the temperature. Question number 102. In the figure above, curve B will be applicable when thermal conductivity of material. Option A, talking about this curve B, it will be thermal conductivity will be option A, increase with increase in temperature. Option B, decrease with increase in temperature. Option C is a very large. Option D is a constant at all temperatures, and option E is none of the above. Correct answer is a B, decrease with increase in temperature. Question number 103. In figure above, curve B will be applicable. It's maybe curve C. In the figure above, curve C will be applicable when thermal conductivity of the material. Option A, increase with increase in temperature. Option B, decrease with increase in temperature. Option C is a very large. Option D is a constant at all temperatures, and option E is none of the above. So first you can see the curve C. It means this curve. So the correct answer is a C. It will be is a very large. Question number 104. The critical radius of insulation for a cylindrical pipe is option A, thermal conductivity of insulating material divided by 2 into heat transfer coefficient at outer surface. Option B, thermal conductivity of insulating material divided by 2 into heat transfer constant at outer surface, and option C is a inverse of A, and option D is a thermal conductivity of insulating material divided by heat transfer coefficient at outer surface, and option E is inverse of B. Correct answer is D. It will be thermal conductivity of insulating material divided by heat transfer coefficient at outer surface. Question number 105. The total emissivity power is defined as the total amount of radiation emitted by a black body per unit. Option A, temperature. Option B is thickness, and option C is area. Option D is time. Option E is area and time. So correct answer is D. It will be time. It means the total emissivity power is defined as the total amount of radiation emitted by a black body per unit time. Question number 106. The critical radius of insulation for a spherical shell is option A is thermal conductivity of insulating material divided by heat transfer coefficient at outer surface. Option B, 2 into thermal conductivity of insulating material divided by heat transfer coefficient at outer surface. Option C is inverse of A. Option D is inverse of B, and option E is none of the above. Correct answer is B. It will be 2 into thermal conductivity of insulating material divided by heat transfer coefficient at outer surface. Question number 107. The ratio of energy absorbed by the body to total energy falling on it is called option A, absorption power. Option B is emissive power. Option C is absorptivity. Option D is emissivity, and option E is none of the above. Correct answer is A. It's called absorptivity power. Question number 108. 40% of incident radiant energy on the surface of a thermally transparent body is reflected back. If the transmissivity of the body be 0.15, then the emissivity of the surface is option A 0.45, option B 0.55, option C is a 0.40, option D is a 0.75, option E is a 0.6. Correct answer is A. It will be 0.45. Question number 109. LMTD for a heat exchanger is given by option A, delta T2 minus delta T1 divided by log delta T2 divided by delta T1. Option B, delta T2 minus delta T1 divided by log delta T1 divided by delta T2. Option C is a delta T2 minus delta T1 divided by delta T2 divided by delta T1. Option D is a log delta T2 minus delta T1 divided by delta T2 divided by delta T1. Option E is a log delta T2 minus delta T1 divided by delta T1 divided by delta T2. So the correct answer is A. It will be delta T2 minus delta T1 divided by log delta T2 divided by delta T1, where the delta T1 and delta T2 are the temperature differences between the hot and cold fluids at entrance and exit. Question number 110. The amount of radiation mainly depends on option A, nature of a body, option B, temperature of the body, option C, type of surface of body. Option D, all of the above. Option E is none of the above. So correct answer is D. It means the amount of radiation mainly depends on nature of the body, temperature of the body, type of surface of the body, and the answer is all of the above. Question number 111. The emissive power of a body depends upon its option A, temperature, option B is a wavelength, option C is a physical nature, option D is all of the above, option E is none of the above. Correct answer is D, all of the above. It means emissive power of the body depends upon its temperature, wavelength, and physical nature. Question number 112. Two plates spaced 150 mm apart are maintained at 1000 degrees centigrade and 70 degrees centigrade. The heat transfer will take place mainly by option A, convection, option B, free convection, option C is a forced convection, option D is radiation, option E is radiation and convection. Correct answer is D, it will be by radiation. Question number 113. Absorptivity of a body will be equal to its emissivity, option A, at all temperature, option B, at one particular temperature, option C, when system is under thermal equilibrium, option D, at critical temperature, option E is for a polished body. Correct answer is C. It will be when system is under thermal equilibrium. Question number 114. In regenerator type heat exchanger, heat transfer take place by option A, direct mixing of hot and cold fluids, option B, a complete separation between hot and cold fluids, option C, flow of hot and cold fluids alternatively over a surface, and option D, generation of heat again and again, and option E is an indirect transfer. Correct answer is C, it will be flow of hot and cold fluids alternatively over a surface. Question number 115. A perfect black body is one which, option A, is a black in color, option B, reflects all heat, option C, transmit all heat radiation, option D is absorbs heat radiation of all wavelengths falling on it, and option is a fully opaque. So the correct answer is D, it will be absorbs the heat radiation of all wavelengths falling on it. Question number 116. Planck's law holds good for option A, black bodies, option B, polished bodies, option C, all colored bodies, option D is all of the above, and option E is none of the above. Correct answer is A. Planck's law holds good for black bodies. Question number 117. If the temperature of a solid surface changes from 27 degrees centigrade to 627 degrees centigrade, then its emissive power changes in the ratio of option A 3, option B is 6, option C is 9, option D is 27, option E is 81. So correct answer is E, it will be 81. Question number 118. Depending on the radiating properties, body will be transparent when option A, rho is equal to 0, tau is equal to 0, and alpha is equal to 1, option B, rho is equal to 1, tau is equal to 0, and alpha is equal to 0, option C, rho will be 0, tau will be 1, alpha will be 0, option D, rho will be 0, alpha plus rho will be 1, and option E is alpha will be 0, tau plus rho will be 1. With alpha is the absorptivity, rho is the reflectivity, and tau is the transmissivity. So the correct answer is C. When rho will be 0 means reflective will be 0, and transmissivity will be 1, and alpha will be also, this means absorptivity also 0. Question number 119. Thermal radiation extends over the range of option A 0.01 to 0.1 mu, option B 0.1 to 100 mu, option C 100 to 250 mu, option D 250 to 1000 mu, option E is 1000 to 2500 mu. So correct answer will be B, it will be 0.1 to 100 mu. Question number 120. A gray body is one whose absorptivity will, option A, varies with temperature, option B varies with the wavelength of incident ray, option C varies with both, and option D does not vary with temperature and wavelength of the incident ray, and option E is there is no such criteria. Correct answer is D, does not vary with temperature and wavelength of the incident ray. Question number 121. Effectiveness of heat exchanger is defined as option A, THI minus THE divided by THI minus TCI. Okay, before we have to read these all options, where the THI means temperature of hot fluid at inlet, and THE means temperature of the hot fluid at exit, and TCI means temperature of the cold fluid at inlet, and TCE means temperature of the cold fluid at exit. And option B is a TCE minus TCI divided by THI minus TCI. Option C is a greater of A and B, and option D, THI minus TCE divided by TH, it will be THE and minus THI. And option E is a THI minus TCE divided by THI minus TCI. So correct answer is a C, it will be greater of A and B. Question number 122. Up to the critical radius of insulation, option A, added insulation will increases heat loss. Option B, added insulation will decrease heat loss. Option C, conversion heat loss will be less than conduction heat loss. Option D is a heat flux will decreases. Correct answer is a B. It means up to the critical radius of insulation, added insulation will decrease heat loss. Question number 123. For infinite parallel planes with emissivity epsilon 1 and epsilon 2, the intercharge factor for radiation from surface 1 to surface 2 is given by. Option A is a epsilon 1 epsilon 2 divided by epsilon 1 plus epsilon 2 minus epsilon 1 epsilon 2. Option B, 1 upon epsilon 1 plus 1 upon epsilon 2. Option C, epsilon 1 plus epsilon 2, and option D is a multiply of epsilon 1 and epsilon 2. So the correct answer is a, it will be epsilon 1 into epsilon 2 divided by epsilon 1 plus epsilon 2 minus epsilon 1 epsilon 2. Question number 124. A heat exchanger with a heat transfer surface area A and overall heat transfer coefficient U handles two fluids of heat capacities C maximum and C minimum. The parameter NTU, it means number of transfer unit used in the analysis of heat exchanger, is specified as option A, AC minimum divided by U. Option B, U divided by AC minimum. Option C, AUC minimum, and option D, AU divided by C minimum. So the correct answer will be D. It means AU divided by C minimum. Question number 125. A composite slab has two layers of different materials with thermal conductivity K1 and K2. If each layer had the same thicknesses, the equivalent thermal conductivity of the slab would be option A, K1 plus K2, option B, K1 plus K2 divided by K1 K2, and option C, 2 K1 K2 divided by K1 plus K2, option D, K1 into K2. So the correct answer is B. It will be K1 plus K2 divided by K1 into K2. Question number 126. A long semicircular duct is shown in the given figure below. What is the shape factor F22 for this case? Option A, 1.36, option B, 0.37, option C, 0.56, option D, 0.36. So the shape factor 22 for this case will be D. It will be 0.36. Question number 127. Which one of the following diagrams represent correctly the gas-gas counterflow heat exchange? Option A, the graph between temperature and area, both are going in the same direction, and in the option B, both are going in the opposite direction with gradually decrease and increase. Okay, and so you can see the curve C and D. So out of these four, correct answer is B. It means this curve where the both gases are counterflow. Okay. Question number 128. The temperature distribution in a stainless fin, thermal conductivity 0.17 watt per centimeter degree centigrade, of constant cross-sectional area of 2 centimeters square and length of 1 centimeter exposed to ambient of 40 degrees centigrade, which A surface heat transfer coefficient of 0.0025 watt per centimeter square degree centigrade is given by T minus T infinity is equal to 3x square minus 5x plus 5x plus 6, where the T is in degree centigrade, x is in centimeter. If the base temperature is 100 degrees centigrade, then the heat dissipated by the fin surface will be option A 6.8 watt, option B 3.4 watt, option C 1.7 watt, option D 0.17 watt. Correct answer is B, it will be 3.4 watt. Question number 129. The ratio of thicknesses of thermal boundary layer to the thickness of hydrodynamic boundary layer is equal to Prandtl number n, where n is option A is a minus 1 upon 3, option B is a minus 2 by 3, option C is 1, option D is minus 1. So the correct answer is A, it will be minus 1 upon 3. Question number 130. Consider following parameters. First is the temperature of the surface, second is the emissivity of the surface, third is the temperature of the air in the room, and fourth is the length and diameter of the pipe, and the parameters responsible for loss of heat from a hot pipe surface in a room without fans would include option A 1 alone, option B 1 and 2, option C 1, 2 and 3, and option D all of them. So correct answer is a D. It means these all parameters will be held to responsible for loss of heat from a hot pipe surface in a room without fans. Okay. Question number 131. Match list first with the list second and select the correct answer using the code given below in the list. So in the first list there is a infinite parallel planes, and second is a B is a completely enclosed body large compared to enclosing body, and subscript 1 for the enclosed body, and C is a two rectangles with a common side perpendicular to each other in option D is a concentric cylinders, and here is the some relation between emissivity. So correct answer is D, this one. According to this answer D, it means A is a infinite parallel planes. It's connected to this relation between 1 upon 1 epsilon 1 plus 1 upon epsilon 2 minus 1, and the completely enclosed body large compared to enclosed body subscript 1 for enclosed body in the relation will be 1, it means epsilon 1. And for the C is a two rectangles with common side perpendicular to each other, it will be connect to this one, it means epsilon 1 into epsilon 2. And the fourth is a concentric cylinder, so this relationship will be connected with this one, it means minus 1 divided by 1 upon epsilon 1 plus A1 divided by A2 in the small bracket 1 upon epsilon 2 minus 1. Question number 32. Also we have to match list first and list second. So in the list first is the parameters and option, and in the list second there is the definitions. So it's explaining about nomenclature: H film heat transfer coefficient, K thermal conductivity of solid, and K subscript fluid is the thermal conductivity of fluid, rho is the density, C is a specific heat, V is the volume, and L is the length. These all is the parameters, and here will be correct answer is A. It means A is connected to the 4. It means time constant of a thermometer of radius r subscript 0 will be h2 pi r0 l divided by rho cv. Over the B connected to 3. Biot number for a sphere of radius r0 connected with this one, it means hr subscript O divided by K solid. And for the C it will be connected to 2, it means this one is a critical thickness of insulation for a wire of radius r subscript 0 is hr subscript O divided by K fluid. And for the fourth, it means the Selt number for a sphere of the radius r subscript O will be connected to first, it means C is connected to the second, sorry, K subscript H and D is connected to first. Okay. Question number 133. Heat pipe is widely used nowadays because option A, it acts as an insulator, option B, it acts as a conductor and insulator, option C, it acts as a superconductor, and option D, it acts as a fin. So correct answer is B. Heat pipe is widely used nowadays because it acts as a conductor and insulator. Question number 134. Match list first with the list second. Select the correct answer using the code. Here's the first list. Okay, first there's the correct answer is a B. Okay, this one. It means the regenerative heat exchanger is belong to hyperbolic curve. And for the second is a direct contact heat exchanger is belong to one, it means water cooling tower. And C is the conduction through a cylinder wall is connected to 4, it means it will be logarithmic curve. And D is a conduction through a spherical wall, it will be connected to 2, it means Lundstrom air heater. Okay. Question number 135. In current carrying conductors, if the radius of the conductor is less than the critical radius, the addition of electrical insulation is desirable as option A. It reduces the heat loss from the conductors and thereby enable the conductor to carry a high current. Option B. It increases the heat loss from the conductor and thereby enable the conductor to carry a high current. Option C. It increases the thermal resistance of the insulation and thereby enable the conductor to carry a high current. Option D. It reduces the thermal resistance of the insulation and thereby enable the conductor to carry a high current. So correct answer is A. In a current carrying conductors, if the radius of the conductor is less than the critical radius, the addition of electrical insulation is desirable as it reduces the heat loss from the conductor and thereby enable the conductor to carry a high current. Question number 136. A pipe carrying saturated steam is covered with a layer of insulation and exposed to ambient air. The thermal resistance are as shown in the following figures below. Which one of the following statements is correct in this regard? Option B is R means resistance of pipe and resistance of air are negligible as compared to the resistance of insulation and resistance of steam. And option C is resistance of steam and the resistance of air are negligible as compared to the resistance of pipe and insulation. And option D is no. Quantitative data is provided, therefore no comparison is possible. So correct answer is A. R steam and R pipe are negligible as compared to the resistance of insulation and resistance of the air. Question number 137. Match the list first and the second and select the correct answer. In the list first, there is a window glass, gray surface, carbon dioxide and radiosity. In the list second, okay, so first answer is correct answer is A. It means this one, and according to this answer, window glass is connected to this emissivity independent of wavelength, and for the gray surface it's connected to the fourth, it means transparency to short wave radiation, and for the carbon dioxide it's connected to, it means emission and absorption limited to a certain bands of wavelength, and radiosity is connected to the rate at which radiation leaves a surface. Question number 138. Match list first and second and select the correct answer. In the first list, there is a momentum transfer and B is a mass transfer, C is a heat transfer. So first correct answer is A, and according to A, momentum transfer is belong to kinetic viscosity, mass transfer is belong to diffusion coefficient, and heat transfer is belong to thermal conductivity. Okay, question number 139. A heat exchanger with heat transfer surface area A and overall heat transfer coefficient U handles two fluids of heat capacities C1 and C2 such that C1 is greater than C2. The NTU of heat exchanger is given by option A, AU divided by C2, option B, E power minus AU divided by C2, and option C, E minus power minus AU divided by C1, and option D is AU divided by C1. So correct answer is A, it will be AU divided by C2. It means a heat exchanger with a heat transfer surface area A and overall heat transfer unit U handles two fluids of heat capacities C1, C2, such as C1 is greater than C2. The NTU of a heat exchanger is given by AU divided by C2. Question number 140. Consider the following statements as pertaining to heat transfer through the fins. Option A, okay, there is not option, these all are the statement. First statement is fins are equally effective irrespective of whether they are on the hot side or cold side of the fluid. Statement 2, the temperature along the fin is a variable and hence the rate of heat transfer varies along the elements of the fin. And third statement, the fins may be made of material that have a higher thermal conductivity than the material of the wall. And fourth statement, fins must be arranged at a right angle to the direction of flow of the working fluid. Of these statements, so correct answer is B. 2 and 4 are the correct statement. The 2 is the temperature along the fin is a variable and hence the rate of heat transfer varies along the element of the fin. And fourth is a fin must be arranged at a right angle to the direction of flow of the working fluid. Question number 141. Addition of fin to the surface increases the heat transfer if under root HA divided by Kp is option A equal to 1, option B is a greater than 1, option C is less than 1, option D is a greater than 1 but less than 2. Correct answer is a C, it will be less than 1. Question number 142. A cube at high temperature is immersed in a constant temperature bath. It loses heat from its top, bottom and side surfaces with heat transfer coefficient of H1, H2 and H3 respectively. The average heat transfer coefficient for the cube is option A H1 plus H2 plus H3, option B H1 H2 H3 power 1 upon 3, and option C 1 upon H1 plus 1 upon H2 plus 1 upon H3, and option D is none of the above. Correct answer is A, it will be H1 plus H2 plus H3. Question number 143. Sun's surface at 5800 Kelvin emits radiation at a wavelength of 0.5 micron. A furnace at 300 degrees centigrade will emit through a small opening radiation at wavelength of nearly option A 10 micron, option B 5 micron, option C 0.25 micron, option D is 0.025 micron. Correct answer is B, it will be 5 micron. Question number 144. The heat flow equation through a cylinder of inner radius R1 and outer radius R2 is desired in the same forms as that for heat flow through a plane wall. The equivalent area A subscript m is given by option A is A1 plus A2 divided by log E in the small bracket A2 divided by A1, option B A1 plus A2 divided by 2 log E in the small bracket A2 divided by A1, option C is A2 minus A1 divided by 2 log E A2 divided by A1, and option D is A2 minus A1 divided by log E A2 divided by A1. The correct answer is D, it will be A2 minus A1 divided by log E in the small bracket A2 divided by A1. Question number 145. Match the list first with the list second and select the correct answer using the code given below in the list. So first of all, correct answer is C, it means this one, and according to this Stephen Boltzmann law is belong this formula is equal to alpha E subscript B, and Newton's law of cooling is belong to Q is equal to HA in the small bracket T1 minus T2, and Fourier's law is belong to 3, it means Q is equal to Ka divided by L in the multiply T1 minus T2, and the Kirchhoff's law is belong to this fourth one, it means Q is equal to sigma A in the small bracket T1 power 4 minus T2 power 4.